Hi guys, I thought I'd use this video to go over an exam-style example of a differentiation question. Now in this question, it's made a bit more tricky with the fact that we're going to have to use two different rules to differentiate. We're going to have to use the product rule because we have a function here multiplying by another function here, and we're also going to have to use the chain rule because inside both of those functions, the cubic and the square function, we have a fifth power function and we have a third power function. So just to remind ourselves, if we've got y is equal to f of x, g of x, the product rule says that dy dx is going to be equal to f prime x g of x plus f of x g prime of x. So that's our product rule. Cool. And what the chain rule says, I'll just change colour. What the chain rule says, so if we have y is equal to f of g of x, so we have a function inside another function, the derivative of this is going to be equal to the derivative of f with respect to this function, so df dg multiplied by the inside function with respect to x. Now you can see here that the g's will cancel out, leaving us with df dx. So I'm not going to run through them anymore because I've got other videos on the product rule and the chain rule, so I'm just going to go about solving this particular equation. So we'll start with the product rule for both of these. What we're going to do is we're going to have dy dx is going to equal, so with the product rule we have to differentiate the front one and leave the back constant. So the differential of the front, we get the 3 and we put it down the front. Seven x to the 5, we leave them inside as it is. We drop the power by 1. And because to differentiate this we have to use the chain rule because we have an inside function out and we have an outside function, the chain rule says that we then have to multiply this by the derivative of g, which in this case g of x is equal to the inside part. So this has to be multiplied by the derivative of g of x, which is 7 times 5 is 35, x to the power of 4, 3 4s are 12, x to the power of 2. Cool. So that's our first part, and then we have to then leave the end bit constant, so we don't change that last part. Okay. Then what we do, the product rule says that we have to then add basically the exact same thing, but instead of differentiating f, which we've denoted, we're going to call this our f of x, and this our g of x. instead of differentiating this, the f of x, and leaving g of x constant, we've got to differentiate g of x and leave f of x constant. So I'm going to take this to the next line. And so we add this to, we're going to leave f of x constant. So 7x to the 5 plus 4x cubed plus 15, all cubed. Then we have to multiply that by the derivative of this. Now the derivative of this is, we'll take the 2 down to the front, so it's going to be 2 bracket 5x cubed plus 11. We can drop the 2 to a 1, so it doesn't really need to be there. And then we have to multiply it by the inside function of this quadratic, which is a cubic. So that the derivative of that is 15x to the 2. Okay, so basically what we've got here is a very, very long answer. It's not very useful to us in any case, but in exams they might get you to do something along these lines just to see if you can identify where the product rule, where the chain rule, and where the quotient rule have to occur. So just summing up, the first thing we did is we identified what functions we've been presented with. So we realized that we had a cubic and a quadratic that were being multiplied together, and that's why we had to invoke the product rule. And then after that, we acknowledged basically that those cubics and quadratics have inside or constituent functions which we have a fifth power function here and a cubic function here. Now because these have functions inside them, the cubic and the quadratic, we then had to invoke the chain rule to be able to differentiate them individually. And then we come out with this quite long-winded answer. And in an exam, you'd just leave it like that. You wouldn't actually try and simplify it unless it says explicitly in the question to simplify. But if you're not told explicitly to simplify it, don't, because it'll waste valuable time in an exam. Okay, I hope that helped, and I'll make sure I get some more videos to you soon. Thanks.